Good morning everyone. Myself Dr. Sakti Prasad. Now today I'm going to discuss about the additive or reproductive properties part 1. Now this reproductive properties is divided in three parts, part 1, part 2, part 3. Now part 1 we have studied the additive or reproductive properties of binomial distribution. In a part 2 we have studied the additive or reproductive properties of Poisson distribution. And now the last part third, we have studied the additive or reproductive properties of normal distribution. Now first we start what is the meaning of reproductive properties. Now we write for the reproductive properties. Reproductive property. Suppose that suppose that x and y are independent and have moment generating function moment generating function moment generating function moment generating functions. We can write also in a shortcut mgfs. Moment generating function mx of t, moment generating function of x, and my of t is the moment generating function of y. And here x and y are the independent random variables. We can write here the independent random variables and have the moment generating function mxt and my of t respectively respectively. Then the moment generating function of x plus y is given by moment generating function. Before you are going to start for moment generating function of x plus y, we know that we know that is the suppose x follows the any random variables, then how to find the moment generating function. In we write the mx of t means that we write the expectation of e to the power tx, and it is depend upon random variable is continuous or discrete. We need to find the moment generating parts. So here is we write the moment generating mxt is equal to expectation of e to the power tx. Now in this case we write the moment generating function of x plus y of t is equal to expectation of e to the power t bracketed x plus y. In a similar pattern, here is x, we can write here x, and now here is x plus y, we can write here x plus y, and after that we write in this form expectation of tx into expectation of ty, and then we write the expectation of tx into expectation of e to the power expectation of e to the power ty. Then what is this? This is the moment generating function. Now what is this? This is the moment generating function of x, and now this is the moment generating function of y, and we can write that moment generating function of x plus y of t is equal to product of the moment generating function of x and y. This is suppose two random variables is given, then we write directly in a product form, and in general we write in general in general suppose moment generating function of x1 plus x2 plus dot dot plus xn of t. Then how to write the moment generating function? In general, we can write in this rule, we can write here mx1 of t into mx2 of t dot 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 mxn of t, and we can write in the product form I is equal to 1 to n, and here is mxi of t, and here is also write the moment generating function of summation of xi I is equal to 1 to n of t. This is the moment generating function. In general, we can write here. This is the moment generating function of in general. Now in binomial distribution, the first we learn the additive properties. Additive, in this lecture we have studies of the additive or reproductive properties. Reproductive reproductive properties of binomial distribution. Binomial distribution. Binomial distribution. Reproductive properties of binomial distribution. Let x follows the binomial distribution with parameter n1, p1, and y follows binomial distribution with parameter n2, p2, be independent. Be independent random variables. Be independent random variables. Then the moment generating function of x. Then the moment generating function of x is what? In a rough parts, we know that. In rough parts, we know that. In a rough parts, suppose x follows the binomial distribution, parameter is n1, p. Then how to write the moment generating functions? So just we remember that the moment generating function is what? Is q plus p into e to the power t, then whole to the power n. This is the moment generating function of x follows the binomial distribution n, p. Now this is the moment generating function of x where the parameter is n1 and p1. That's why we can write here the moment generating function is q1 plus p1 e to the power t whole to the power n, and moment generating function of y of t is equal to q2 plus p2 e to the power t whole to the power n2. Here is n1. Yes, we write the n1. Now, what is the distribution? What is the distribution? What is the distribution of x plus y. What is the distribution of x plus y? Now we have we have moment generating function of x plus y of t is equal to moment generating function of x into moment generating function of y, since x and y are independent independent random variables independent random variables. And after that, x follows the binomial distribution. X follows the binomial distribution. That's why we write the moment generating function is given here. Moment generating function is given, and y is follows the binomial distribution with parameter is n2 comma p2, and that's why we can write here moment generating function of y. And after that, here we write the q1 plus p1 e to the power p e to the power t, then whole to the power n1 into moment generating function of y is q2 plus p2 e to the power t and whole to the power n2. Now this is the equation number 1. Since equation 1 cannot be expressed cannot be expressed in the form q plus p into e to the power t then whole to the power n. Therefore, x plus y is not a binomial variable, not a binomial variables, and we can show that x plus y is not follows the binomial variables. Hence, hence, in general, in general, the sum of independent binomial variates is not a binomial variable, is not a binomial variables. This is the important parts. The sum of independent binomial variates is not a binomial variables. In other words, we can say that the binomial distribution does not possess the additive or reproductive properties. However, however, we take if we take P1 is equal to P2 is equal to P and Q1 is equal to Q2 is equal to Q, in equation 1, now the moment generating function x plus y of t is equal to what? Here is Q1 is Q and here is P, then we write here Q1 plus P into e to the power t then whole to the power n1 into q1 plus p into e to the power t, then all to the power n2. And here we have seen that the base is same, then power must be added. We can write the q plus p e to the power t and all to the power n1 plus n2. This is the moment generating function of x plus y of t. This is the moment generating function. This is the moment generating function. And now we can write here which is the moment generating function of a binomial variable with parameters with parameters n1 plus n2 comma p. Hence, by uniqueness theorem, by unique theorem of moment generating function, we can write that x plus y follows binomial distribution with parameter n1 plus n2 comma p. Thus, the binomial distribution, binomial, binomial, thus we can write here binomial distribution possesses the additive or reproductive property for P1 is equal to P2. Now, in general, in general, in general, we can write here if xi I is equal to 1 to dot dot k are independent binomial are independent in binomial variates or variables, that is not difference, with parameters with parameters with parameters ni comma p I is equal to 1 to dot dot k. Why you take the ni? Here is the xi is involved. Xi is the independent random variable, that's why we write in the parameter of ni comma p. Then summation of xi I is equal to their sum. Xi follows the binomial distribution with parameter is what? I is equal to 1 to k ni comma p. This is the general formula for the reproductive properties or additive properties of binomial distribution. So now we go for the one example how to use the additive properties of binomial distribution. Now example if the independent if the independent if the independent random variable random variables x comma y are binomially binomially distributed respectively respectively with n is equal to 3 comma p is equal to 1 by 3 and n is equal to 5 comma p is equal to 1 by 3, then write down then write down the probability that x plus y is greater than equal to 1. This is the question. Now go for the solution here. Question is, suppose the two random variables by xy is follows the binomially distributed. Means according to the question we write x follows the binomial distribution with parameter is given n is 3 and p is 1 by 3, and y also follows the binomial distribution. Here parameter is given 5 comma 1 by 3. Now here p and this p both are equal. That's why we know that here is p. We can write that here the p1 is equal to 1 by 3 or q1 is equal to also 1 by 3. p1 not p2. p2 here is p1 is equal to 1 by 3 or p2 is equal to 1 by 3. Here is a p1 and here is the p2. Both are equal means by the additive properties, by additive or reproductive reproductive property of binomial distribution of binomial distribution we can write we get x plus y follows binomial distribution with parameter is n1 plus n2. Here is 3 plus 5 comma p. P is what? 1 by 3. Now in rough parts we know that suppose x follows the binomial distribution with parameter n comma p, then what is the probability mass function? What is the probability mass function? Here we can write x equal to x is equal to ncx p to the power x q to the power n minus x, and now x is equal to 0 1 2 dot dot n, and here p plus q is equal to 1. Now in this case we get the x plus y follows the binomial distribution, that is x plus y binomial distribution is 8 comma 1 by 3. Now the probability mass function probabilities mass function of x plus y is what? Here we write the probabilities mass function. We can take x plus y is equal to r. Now we write n is what? N is given in according to the n is given 8. C, X is what? R. And now we write P. So what is the values of P here? P is what? These values are P 1 by 3 to the power what X, then we can write for R. And now we need for Q. Here the formula is Q. Then how to find the Q in this question? How to find the Q? Q is equal to 1 minus P. Now in our question we can write 1 minus 1 by 3, that is coming what? 2 by 3. Here we write 2 by 3 whole to the power what? N minus x. N is what? 8 minus x is what? R, in according to the question. And now R is equal to what? 0, 1, 2, dot 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 8. This is the binomial distribution, binomial probability mass function of x plus y. Now, now we find that hence we find the probability of x plus y is greater than equal to 1. We converted probability 1 minus probability of x plus y less than 1. Again we write 1 minus probability x plus y less than 1 means what? R. Here is R less than 1 means what? R is less than 1 means what? 0. We can write directly x plus y is equal to 0. Means that we can write here 1 minus 8c0, 1 by 3 to the power 0, and 2 by 3 to the power 8 minus 0. Now after that we can write 1 minus, this is what? 1, and this is what? 1, and here is coming 2 by 3 to the power 8. And now we can write 1 minus 2 by 3 to the power 8, and this is the answer. After calculation we get 0.96098. Now thank you guys, thank you for watching my video. So please like, comments and subscribe.